I've heard them all.
Get ready for
my second
class.
breakfast.
Okay, integrals.
Good. Proud.
Our favorite.
Well, they're better than the first one.
Oh,
Yes,
man.
Ave does like integrals much better than derivatives, and it doesn't.
It doesn't make
I'm not
sense.
sure why, but it does happen.
It doesn't make intuitive sense.
Intuitive. It's not intuitive.
My galaxy brain have expanded
Yeah.
to the reaches of the galaxy.
Ooh, that would be
lit.
fun.
It was lit.
I'm glad you enjoyed that.
Music on a whole other level, which is wild because I already understand music.
I tried to teach Griffin how to sing someday, which was very entertaining.
Perfect.
We're going to start off with
Griffin will realize that they get another 4 weeks when he hears that.
3E.
Hello.
I must remember how to do these.
So if you may or may not recall, I mentioned last class that everything through 3D follows the same, it's a reverse chain rule of some kind. So on this one's, a lot of times you're using something like, oh, I've got u to some power with a u prime. For example, hint, hint, C is like that. C you can write as u to some power times u prime. And that, when you integrate that, you just end up with u to the n plus 1 over n plus 1. Or maybe you're dealing with some other chain rule where it's just as an example, there's a few different forms you got to look out for. One is u prime over u would give you, who remembers this one? What did u prime over u give you?
Lateral
Natural log of u. So
line.
that's what you're using for a lot of these. And then going forward, we're going to talk about stuff like this. What if you had, for example, the cosine of u with a u prime? Same thing, the u prime is going to disappear.
Goodbye.
So that's just a brief, it's not an exhaustive summary, but that's just a few things we're looking out for. This one, though, a little bit different. But the answer is very interesting.
Thinky. Well, thinky.
You got a thinky winky on this one. Okay.
Yay, I have one sharp pencil.
The mood.
You got to look.
The trick is, I'll show you the trick, and I'll give you a second to think about what is this doing?
Actually, yippee.
That's the trick. Do you see?
Do you see? Yes, I see.
Well, okay. I'll give you a second to look at that. I need some sody pop.
You do?
I need some of my bang sody pop.
Lollipop, lollipop, oh, lollipop.
Where did you get that from that sentence?
Sody time.
Sody pop, lollipop.
Sody time.
Pop, pop.
Oh God.
Exactly, yeah. You guys heard what Caleb said? You use a technique like this a lot of times in doing like basic arithmetic.
You're also one of my favorite people.
Sody pop time.
Oh my goodness. Well, at least I'm not like mad.
We get an extra hour of math?
Yeah,
I could be used to the factor. Instead, I choose to laugh at sody pop, sody pop.
You're gonna go pop, pop.
Sound
like a-
Okay,
Like a
so let's look at why this works. This right here is one nougat.
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 I'm going to think of that as one little nougat of information.
Yeah.
Now what that does is I go, oh, well, I guess the top is a nougat plus another thing. So what can I do when I've got a thing plus a thing over a thing?
You can split it into
You can split it into two different fractions.
Oh
So we're
my
gonna
goodness.
Sorry?
I really
plus
I
so
know, man.
HMU if you have question right now. Just TBH me.
Where'd the plus one come from?
What?
How is that easier
Could you?
Well, here's the thing. It's a good point. what I kind of jumped the gun. How do we, well, why am I making it complicated? Well, this is actually the easiest way to do it. Because what are you maybe thinking of when you see this? It's a really good point, because you're like, well, how am I going to know to do this? Well, you're going to start off with your basic ones and be like, can I possibly write this? If this is going to be a U prime U type dealie, this dude's got to be U, right? There's no really way around that. But if he's U, then U prime is 2, and I've got this pesky X there, and he's not going anywhere. So that means we have to like try something more complicated. Does that make sense?
Yeah. Could you go how you got from the top one to the circly one?
This?
Yes.
I subtracted 1 and I added 1. So why is that okay?
Oh,
Well-
okay. Now I see.
I've added 0 to the top. That doesn't change anything.
Okay.
So there's 1, in hindsight, do I know it's okay? Yeah, because I didn't actually change anything. And then 2, why is it a fruitful approach? Well, I've turned the top. See, I created a nougat.
Mm-hmm.
Mr. Nougat's there now. So watch what's going to happen. Does everyone understand here to here?
Yes.
And then do we understand here to here?
Mm-hmm.
Now, well, look at this guy.
1.
That's just 1. So the integral of 1, I'm actually also going to split the integral into 2. You don't have to do this, but it's probably going to be helpful.
Pinky but Mickey.
Exactly. Because is that guy easy?
Yeah.
Is this guy easy? Almost. I just need to, what do I have to do to this 1? Turn that into a 2, and then balance it out with a 1/2. Make sense?
Yeah.
So my final answer is this. That X plus natural log of 2x plus. Isn't that lovely?
That is lovely. I'm a fan. I really had to know what jump the gun, like where that originated from.
Where does it come from?
It comes from track and field,
Oh,
which
Makes a lot
makes
of sense.
sense.
that makes sense.
Yes. But I was like, jump the gun. Why would you jump?
And
that?
that
I
saying
get it.
couldn't be. Well, I guess it could
It's
be
not
pretty
that-
old,
well, yeah.
but it's not old and
So
Same
what is like
age.
looking at
yes.
that might be
Right,
long.
we're getting-
One
I'm
of the
I'm
X,
with you.
like
It makes
there's an
perfect
X on
sense to me.
the top or bottom or any value and it's like is it the same power? Is this when you're gonna add
Saying.
0 to the top? Like at the general.
I would say that's a good clue. I can't say that's 100% of the time going to work, but did you hear what Winslow said? He said, could you say generally that anytime the top and bottom have like the same degree, like these are both linear, with this technique, I would say, yeah, that's something you want to probably keep in the back of your head that, yeah, if they have the same degree, this is probably going to be a method. The thing that you're really looking out for is, can I transform the top very easily into being the same as the bottom with an extra, with a plus sign? Feelies good or yeah?
Feely's engaged, man.
Engaged.
Okay.
Oh
So
my God.
hypothetically, you could do the
In
same
Florida,
exact thing for
I
F
want
that we
some
just
of the-
did.
Potato
So
salad that we got with the one.
let's do
Oh my God.
another
It was
weird
the best
one.
potato salad I've ever had in my entire life.
Weird one?
Jesse.
I really want that
Random.
potato salad.
So would 7 be the same way, or
It was so
F.
good.
Yeah, why don't you guys try F real quick? What's gonna be the trick?
Plus one.
The first step
minus
to add 1 and subtract 1 from the numerator.
Jake, well, look, man. I don't know. I barely made it here.
You're doing great, Jesse.
Thank you.
You're doing awesome.
I try.
And then we'll, once you guys are done with that, we'll move on to the next page that has a few more of these. And
Hmm. Hold on.
are those beans?
No.
Yep.
Acai beans.
Sure. Yeah, no, that would be correct.
Lollipop, lollipop,
Oh my
lollipop.
Jeffrey.
Ba-dum-bum-bum. Sweeter than candy on a stick. Huckleberry cherry alive.
Jesse.
Oh.
No.
It's mine. Okay. Sorry, I'm done. I'm done.
Jesse.
That
I
was it.
barely made it through my mother this morning.
Okay, I'm
No.
sorry. I'm sorry. My bad. Oh, I'm sorry.
In the way that she's just pushing all the buttons.
If you need to, you can come stay at my house.
That might be a good idea.
Okay, yeah.
Did you get it, Kate?
Slow me down.
Has everyone had a chance to answer it?
I'm stuck on third.
What'd you get, Kate?
X minus natural log of X plus 1 plus C.
Mm-hmm.
X minus the natural log of the quantity x plus 1?
Yes.
Plus c. That sounds right.
Yeah, you
Good.
got that.
Let's look at a couple on 4. Are you okay with that?
Yes.
So 4a is, I mean, that one alone is pretty challenging. Can we figure out, and I'll give you, this isn't a very big hint, but
No.
this is the way I'm going to space this.
Oh.
I got that.
Oh. Not that step. This
No.
step. This step. Okay, here we go. Okay, sorry. Okay. I didn't understand which step that I left out that you needed.
Just for funsies, does anyone remember what shape this is, if you were to graph?
Is
This,
it like
Is it
a?
100
Yeah. Is it like?
it starts with an L or an S.
a line?
Slowly.
Linear.
Logistic and or sigmoid.
Yep. Nope.
Nobody remembers that.
Snail, correct, yes.
Snail.
Snail.
Isn't that a Beaver somewhere? What's that song?
Just 1 over x plus 1? What makes it that?
Okay.
That song was
So
a
that's
bop
u
though.
prime over u.
It's
So
hit
like
different.
this is the u prime of this. So then this is. Does that make sense or does it not make any sense?
Well, I know what
Doesn't that
u
feel when
prime
a
over
slap
u
just hit
is, but I
different?
didn't know what you put on
It's a
the
great feeling.
outside.
Oh, you don't need to put anything on the outside because 1 is already the u prime.
All right, who thinks they've got an idea of what we should add? Add to the top and subtract from the top.
Sorry. That's all right.
Could I add an e to the x to the top?
Probably.
And then subtract another e to the x in one move like that?
Whoa.
Yeah.
Is it fell swoop in one fell? Okay, sorry. I'm sorry, but I just realized that I didn't
Okay.
actually know
So
the thing that I
what
was
that
saying.
does, now let's see, is that gonna work? So the top
Yes.
now I've got, well, I gotta split up into 2 fractions. Kind of defeated the purpose. What else would I do with it? So I've got now e to the x plus 1 over e to the x plus 1. That'll work out nicely. Minus e to the x over. Does that make sense?
Yes.
Now, what's the integral of that going to be? Yeah. I'm going to skip the intermediate step here, if that's okay. Because that would become, well, I'll draw it over here if you're wondering. It's the integral of 1 dx plus the integral of, sorry, minus, my bad. Minus the integral of e to the x. Now, what did we create here? What form is that? U prime over u. So this is going to become natural log of u.
Line.
Isn't that neato burrito?
Nito burrito. Sounds really good. Yummy, yummy lunch.
How's it going, Rafe?
All over a place today.
Did you have a lit weekend?
Yeah, I know.
All over.
Yep. It's fucking everywhere, man.
Yup.
I don't know what's going on. But I do know that that's my favorite mug of all time.
This bank soda pop can?
Yeah. I have potential. Isn't that so funny? Because it has potential energy.
Jesse?
All right.
Jesse.
Look at the one below.
I want
C.
that.
That one's challenging. Challenging.
You got it.
You all love a challenge, don't you?
Oh, me too. Yeah.
Don't you?
What?
Yes, maybe, possibly.
I lost the question. What did you ask?
Look at this.
Lollipop.
Thinky,
Oh, Mickey.
winky.
Oh. It doesn't.
You just added perception
Let's say that was your first
on the top.
move.
Because then, wait here.
It's not a bad start though. So if I add one and subtract one. Yeah. This one's pretty tricky. Although when you see it,
Oh, can you just do x squared times x?
I'm gonna add
No,
x squared
I'm
and
still
I'm
thinking
gonna
of, and
subtract
then
an x
subtract
squared.
one, do that.
That's how it works.
that is close.
Then I have.
Unfortunately, what makes these as math problems not like the most interesting is that there's really only one answer. There's only one approach that's going to work out. So the answer here would be adding x
Okay. That is.
and then subtracting x. So first thing to check for, did we change the numerator? No, we didn't change the actual thingy. Now take a moment.
Aha, you can factor out.
A lot of times, even when you see the approach, you're still like, what is that going to do, right? So here, though, do you see what's going to happen? If not, it's okay. We're going to see it when we split it up. Maybe it'll be more obvious.
Mhm.
But so this guy, I've got x cubed plus x. So maybe you see it now. What's going to happen there?
Yeah.
Minus do you guys see what's going to happen with this guy?
Yeah, factor out next.
If you factor out an x from the top, then you'll see that you have an x squared plus 1 divided by x squared plus 1. So this guy would just be the integral of x. This guy doesn't need it. Well, I guess I could go ahead and change him now. That it's a good spot for an intermediate step here. What needs to be done to this guy to make him more friendly?
By 2.
Yeah, you're gonna make the top a 2x, because now he has that u prime over u form that we like, but I gotta put a 1/2 out there to balance him. And so now we're ready. Spaghetti. This guy. Isn't that nice?
That is nice.
Ooh.
Look at that. Integrale. Oh, that's the Xbox song. It's different.
Yeah.
Jesse, there's not really a. It's just a little ring.
Bro, you guys know that feel when you put into your Sonic the Hedgehog cartridge into your Sega Genesis and it goes, Sega, am I right? That's like a good feel. Pretty relatable, right? No cap?
Yeah, relatable.
Oh, you're forgetting about the GameCube.
GameCube? Or that feel when you're trying to go on the internet and then your sibling has to use the phone and you're like, bro,
No.
get a life. Right, guys?
No.
Bro!
The modem be like,
Bro!
right, guys?
Yeah.
You guys know what I'm
Yeah,
talking
remember
about.
when you were downloading a file and then you would go away for 20 hours and
Yeah.
you come back and it's at 2%?
Yeah. downloading a song, it's going to take a couple hours. Okay. Sorry. I'll be quiet.
Can't relate.
Do
Didn't have internet till
you
freshman year.
wanted to download a song, but it was too much for your MP3 player, so it just shut off. And then you never got to listen to any music. Yay.
What's up?
Oh, my mom got me the arthritis pill bottle, so then it's easier for me to open. No.
Did I take mine? Yeah.
I hope you did.
I think I took mine. It doesn't matter. It's a cumulative thing. I can miss one.
Okay,
Why not just take them all at once?
so I'm
Try.
going to move on to two more things, okay?
Well, there will be nothing
Okay.
to press.
So you'll have to come back and knock those out when we have some work time. I want to look at number 5 with you. Just do 1 or 2 examples. I only put 6 on here. It's a really brief review of a really easy thing. It's just to jog your memories about definite integrals. So,
Indeed.
So we know about this now, hopefully.
Had to read what it said.
Yeah, and then if you put a number there and a number there, that just gives us a lower and an upper bound. It also adds an extra level of meaning to this, because then when you see these, you really start to, your mind should go towards oh yeah, if you went from 1 to 2, this curve would have a certain amount of area bounded underneath it. And this integral is going to tell you this area. That all ring a bell? Just so one example, if this were like a velocity function, the area would give you
The average velocity, is that what we're saying?
it's related to position. It would be the displacement.
Oh, yeah, sorry.
So
I don't know what I'm saying.
if this is a velocity function, the antiderivative would tell you about the position function, but when you actually plug in the 2 and the 1 and subtract, it gives you the displacement, the change in position. The net change in position. So, notation review. What's the integral of 5 over x?
Ooh.
Is it just natural log? 5 natural?
5 times the natural log of x, or
Mm-hmm.
And then evaluated that one.
this is one, make sure you know that one. It's a pretty basic result, pretty fundamental. You can pull the 5 out if that helps it make more sense. 5 times 1 over x, and the antiderivative of 1 over x is the log of x. And then you put this bar here. You go from 1 to 2. And what that bar tells you is you're plugging in a 2, you're plugging in a 1, and you are subtracting. Like that. Make sense?
Yep.
Yes?
Mm-hmm.
Okay. How bigly is this number here? What's the log of 1?
0.
So the answer to this is just 5 times the natural log of 2. Good morning again.
Well, can I see Jesse?
Okay.
Jesse, what'd you do?
You walked out.
Roasted. BT dubs, just saying. It wouldn't be inconceivable to see the answer written like that. Inconceivable. You understand that?
32? No.
5. Oh, I got it. No.
No, still don't get it.
5.
Nothing in my mind. 32.
So,
Oh.
just saying
Nothing in my
Uh,
life thinks 5 times 2, 32. Does it matter?
It doesn't.
I'm saying these are both totally fine answers.
Okay.
Just be aware that, it would be like if you're doing a math problem and you got an answer of 4 over 6. That's also the same as 2 over 3.
Yeah.
So the final answer is 2 plus 5. Well, you might also see that number written as 7.
Perhaps, maybe, I don't know.
I'm saying there's
No,
often
no,
two
no,
different
no.
ways of writing a number.
Yes. Perhaps.
Um,
My bad.
so
Thank you. Oh, thank you. Except for I've been saying Bobinky for some reason.
For some winking.
Let's look at B. B is kind of similar. It's
Bum, 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 bum.
integral of 3 to the x. Then we're going to move on after another example. The idea is pretty simple, right? If you can take the antiderivative, you just plug in the numbers. So the next one would be, so either you just know this is a rule, how to integrate this, or you know the derivative rule and you apply it like this. What number has to live here for this to work out?
Yeah.
Log of 3.
Yeah.
Because I know that the derivative, so let me write it over here. I know that the derivative of 3 to the x is log of 3 times 3 to the x. So in order to go the reverse direction to integrate, I need that log of 3 constant to be there.
Oh.
Now, I would say that most Quackmalus students just, they consider this one of the set of things that they just have to memorize. They just memorize that the integral of 3 to the x is 3 to the x with a 1 over log 3 constant attached. It's obviously, I think it's good to understand why that's there. It's because of this. Oh, why am I putting a plus C, bro?
Lame.
That was not every day, bro. It's the opposite. Not good.
Oh my god.
Wow.
Bro.
Scared the shit out of me.
Yep.
Jesse.
I'm sorry.
Naughty language.
I'm
Great, it's
sorry.
gonna be scarred.
I'm
Griffin?
sorry. My
Scarred.
I don't have a filter today.
No naughty language, please.
Okay. Scared me a lot.
Okay. So, are we gonna get any sort of wacky answer here? I mean, I don't know. Let's see. Plug in the 2, you get 9. Plug in the 1, you get 3. I got 9 acorns minus 3 acorns. So I have 6 acorns. Cool beans? You guys see why the answer would be written like that?
Yes.
Yay! How are our feelies? How are the feelies doing? Dylan, feelies engaged?
Sleepy is awesome.
You're sleepy?
It is Wednesday.
Is the late sun setting hindering your sleepy schedule?
No.
Okay.
Sun or night shines.
That's that fine with you guys?
Yeah.
No questions? Okay. So last thing for today is going to be a quick overview of some more just simple. We'll just do this one page because they're going to be really quick.
The 6?
Yeah, 6. Next page. So think about this. What's the integral of the sine function? Sine of x.
Negative cosine function.
Very good. So these be, I mean, if you know your derivatives, these are very straightforward. So the derivative of sine is cosine. Okay. So like, for example, B, at least in my mind, for some reason, the derivative of sine is cosine is like the first one. I don't know why. So the integral of cosine is just sine. That's probably the easiest result, right? Because the derivative of sine is cosine. The antiderivative of cosine would be sine.
Mm-hmm.
But the antiderivative of sine is the opposite of cosine. You understand that? Mm-hmm. Okay. I'm gonna let's skip C and D temporarily because E and F are actually really easy.
Yeah.
Because E is asking, yeah, because when you see this, this is a good example of one where if you don't just know this one, it's really difficult. But what function has a derivative of secant squared? There you go. Make sense? You feel okay about that? Okay. And F, what function has a derivative of cosecant squared? Oh, cotangent turns into negative cosecant. So negative cosecant squared. So cosecant squared will turn into negative cotangent. Pretty painless, right? Not too confusing.
Yeah.
So now we gotta look at tangent. What was that? What's that?
Earthquake.
Her mom.
It's my mom? Wow, that's so savage. Did you record that on TikTok? Bruh! It would have been so epic. God, missed opportunity.
Don't worry, it's
Life
on
is
the
full
YouTube
of-
video.
Yeah, it is on YouTube forever. All my Twitch followers just heard that epic joke, so it's good. Oh, the donations are flowing in now. Man, the chat is just going crazy.
You know.
Tangent.
So weird.
So when you see this, at first you probably go, wait a second, I don't know any function who has a derivative of tangent. So what's going on here? Who thinks they know what I'm gonna write here?
Is it like a
Sine. Sine over cosine. This is it's practically the definition of tangent. Okay, feel good about that? Now, so wait a second, that is looking kind of, what do we always look for when we see a fraction? It should be the first thing you think about. Is that a u prime over u?
Yeah.
Almost, very close. Now it is, see? You see the u prime over u?
Yeah.
U prime over u. And so I guess the answer is, don't forget the negative out there. And then here's one where you probably, what's weird about this one is anytime cosine is negative, this would be undefined. But tangent is only undefined at discrete values at like pi over 2, 3 pi over 2, 5 pi over 2. So this one's one where we probably are like, we have a good reason to be like, yeah, we want that absolute value on there to make sure that this is going to be, notice this would be undefined whenever cosine is 0. We've ensured that it's never negative with the absolute value bars, but you can still have this take on 0, but cosine is 0, the same places that tangent is 0. Pi over 2, 3 pi over 2, 5 pi over 2.
Yeah.
All right. Likewise, the cotangent.
Wait,
What up?
why did we have to add that negative? Because isn't like the, never mind, just kidding.
We had to change that
I was-
sign to be negative sign.
Yeah, I was thinking u prime was the general, not the derivative, but now I get it.
This time it won't be necessary because it's all just, if you write cotangent as cosine over sine, you've already got u prime over u, it's just right there for you. And so the answer to this one would just be the positive natural log of the sine function. That's kind of weird, right?
Yes.
Okay, so Yeah, so if you look at like 7 and going forward, 7 and 8 and 9, those are gonna be other examples of like what G and H are about. So let's end on these G and H. Looking at G, do you see how the chain rule is gonna come into play here? What up? Oh yeah, what's up? Yes, of course. It's the modal question I receive.
Okay.
Oh, modal being most common.
Right.
Mean, median, mode. Reminds me of a riddle for you guys.
Oh, does it?
Apparently, it's really famous. Okie dokie.
Is it how many times does Jessie have to be in this building again until she never has to be in this building again ever again?
No, that wasn't it. You can make that riddle. So, I alluded to this at the beginning of class.
Sorry.
Here's my question for you. So tell me if it's making sense for you, I guess. Where is U?
Okay, right,
Plus one.
This dude, that's U.
Is it?
Do I have a U prime?
Not yet.
Yeah. Almost, you have to.
Almost.
You have to, yeah,
So now, I don't have U prime times U to a power. It's not that kind. I have U prime times cosine of U. So whenever you have this, what's that going to turn into? U prime cosine of U would just turn into sine of U. So therefore, the answer to this question is 1/2 times the sine of U. That's pretty painless, right? Pretty simple. H is a little different. H is a little bit more complicated. Are there any questions before we move on? For H, same question. Where is U? It's not the 2x.
Darn it.
To make this one a little bit.
Oh, that's the cosine.
And the hint is that 3.
I was getting sick.
That exponent is a big, big hint that this is of that form. It's somehow going to be a U prime times U to the 3rd. Does that make sense? It's not quite there yet. It's almost there, but. And what's the integral of U prime U to the 3rd? U to the
4th over 4.
4th over 4. So let's look at this. How do we, if this guy, this whole thing here is the U, U prime would be what? Negative 2 sine of 2x, right? Do we all understand that? Or are we confused? Yeah, of course, I'm not done yet, right? I need to.
No.
I gotta also put a negative 1/2 out here to balance it. Do we all understand why if that's U prime?
Yes.
That makes sense? And we understand how this is of this form? Okay. So we have a negative 1/2 times U to the 4th over 4 plus a constant. Bad? Good? And then, is there a nicer way to write that? Yeah. Negative 1/8 times cosine to the 4th Cosine of what? You could keep the 8 on bottom of the fraction if you like. Yeah. Those are equivalent. Okay. Any complaints? Questions? You okay, Lillian? Gonna make it? What? No? Okay, sorry. Sorry to hear that.